So if you consider, you'll see that the previous class that we had was on the proof of the formulas that you are going to use in the applications of the sine rule. That is the use of the sine rule. We had the part of the proof where you managed to work with everything that you need, like the proof of the sine rule. But in this case, you are not proving any formula. You are to use the formulas. Exercise 2 that you are given, find the value of x in each triangle. The diagrams are not drawn to scale. Give all answers correct to 2 decimal places, as we are told that these diagrams are not drawn to scale. So you do not measure these. You have to calculate. Find these values of x. You must calculate whatever that you are given. All right. So remember that from the sine rule, we have got a condition where we can apply A over the sine of A, which is equal to B, over the sine of B, which is equal to C, over the sine of C, where these A, B, C are the sides, and these A, B, C are the angles. We can also have the same formula as the sine of A over A, which is equal to the sine of B, over B, which is equal to the sine of C over C. Remember, these formulas that we are seeing here, or the rules that we are having, are used on a condition where the angle has a corresponding side, another angle has a it's an angle side pair. If that condition is happening of an angle side pair, if this is happening, we can consider the use of the sine rule. Let us consider our first question on number 1. We are asked to find x, and there we are given 35 degrees opposite to this x, the 54 degrees opposite to this 33. As you can see, that is the angle side pair, That condition, sine rule can be used. So in this case, x that we are calculating is representing a side. That's a side. And as I said, it is just best that you write the sides on top if you're calculating the side. So do not worry, it's just A over sine A, B over sine is what you're calculating, which is x over sine of the angle that you're given, which is the sine of 35 degrees. It must be equal to the other side, which is a pair angle that is corresponding to. That is 33 over the sine of the angle that you're given, which is the sine of 54 degrees. So take note, side over the sine of the angle, side over the sine of the angle, opposite to that side. So that is the side pair concept, or angle pair concept, angle side pair that you're given. So we can calculate x. So the concept is we can cross multiply, which is up to you, or you can simply multiply by the sine of 35. As you can see here, we are dividing. So we can remove this by multiplying by the sine of 35, which is fine, or you can cross multiply. It's up to you guys, the way that you understand. X times the sine of 54, that's x sine 54 degrees is equal to 33 times the sine of 35 degrees. So that is 35 degrees in this case. We need to calculate x, so we can remove this sine of 54. Remember, that's a product here, so you can simply divide by the sine of 54 both sides. So simply divide by the sine of 54, you are going to obtain the x. So x in this case is equivalent, or is equal to this part. So x is equal to the whole of this part, which you can use your calculator in the simplification. Remember, we're told to 2 decimal places. So in this case, I'm just going to have this on our calculator. Just fix our calculator to 2 decimal places. All right. So there we have got 33, the sine of 35 degrees, everything over the sine of 54 degrees. So that's 54 degrees, which is going to give us 23,40. All right. So that is to 2 decimal places. Sorry. So that's 23,40 centimeters, the units for the sides that you're given. You use the units that you're given. So they were given centimeters. We have to use the centimeters, right? If you're given meters, you have to use the meters. Yeah. Use the units that you're given. All right, so that was our question number one. Just like that, we can just apply the sine rule. So like I was saying, on this part, you could have just cross multiplied in this man, instead of you cross multiplying this times this other side, you can just remove the sine, this one, because it is dividing. So you can just multiply by the sine of 35 degrees here. You also multiply by the sine of 35 degrees. That's simply removing that. You are left with x. So many ways that you can actually evaluate or simplify these problems. So many ways that you can have. All right, let us consider number two. We also have a condition where we need to calculate x, representing the side. But if you check, this side does not correspond with the angle. We are not given the angle there. So this is invalid for us to use the sine rule. So what are we supposed to do? Find at least the angle that you are given. So that's why we are given these two angles, because we do understand that angles in a triangle, they add up to 180. So to obtain the angle at A, we are simply going to subtract these angles that we are given from 180 degrees, the 28 degrees and the 54 degrees from 180 degrees. That is, you must remove these angles that you are given, since they are not part of our angle. They are not part of, this A. So we must remove this from 180 so that we remain that we have the A. So that was going to give you 98 degrees if you simplify properly. So having an angle of 90 degrees here at A, we can see that now we can use the sine rule. The side that you want to calculate corresponds to the angle, and there is a side here corresponding to the angle. Remember the side angle pair that you're given. So x to this angle, 18 to this angle. You can use our sine rule. So that means from the A over sine A is equal to the B over the sine of B, which is equal to C over sine of C. You can just take whatever that you want. That is A, which is x, over the sine of the angle that is corresponding there. 98 is equal to the other side to the angle that we are given, which is 18 over the sine of what? 28 degrees. So like I said before, you need to remove this sine 28. So you can just remove this by multiplying. That's a division. So you multiply. You also have to multiply this side by the sine of 98 degrees so that this can cancel. So x is simply equivalent to this, which is just the same as, guys, there's an over one. So it's simply like this, 18 sine 98 over the sine of 28. That is what it means. We just use the calculator there. No one is going to ask you anything there, guys. You're going to obtain your full marks. So as we see that our calculator is already fixed to 2 decimal place. So you're going to have 18, the sine of 98 over the sine of 28. So this is over sine 28 like this. So as a decimal, that's 37.97. So that was going to be 37.97. And these are centimeters. Remember, you are referring to the side. You are calculating the side. So that is considered the units in centimeters. That is what we had. All right, so that was it on question number 2. Question number 3, using the same concept, but this time you're calculating an angle, which is A. And when calculating the angle, we're going to talk about the issue of the ambiguous state that we can have. Angles can differ. All right, let's see what we are given. That is question number 3. But in this case, still we can see that the application is not going to change. The angle that we want is corresponding to the side. Then the side that you are given and the angle that they do correspond. So meaning to say the sine rule can be used. Sine of A over A is equal to the sine of B over B. When calculating the angles, just write the angles on top. Not to say if you use the A over sine A is wrong. No, you can just use whatever that you understand. So that means the sine of the angle that you want to calculate, which is angle X, over the side corresponding to that, that is 71, is equal to the sine of the other corresponding part that you are given, the sine of 52 degrees over the opposite side to that, which is 68. Just like the previous case, we saw that when dividing, you can just simply multiply by what is dividing to remove it. So you want to remove the 71, which is dividing, so simply multiply by it. You have removed that. So that's the sine of x is equal to this whole part that we are seeing. So you can just use your calculator to simplify the decimal part that we are going to have. But in this case, I'm just going to bring back my calculator to the normal mode because we do need the exact decimal. So that's okay. Let me just remove this, go back to the normal. All right. So that's we have got 71 times sine of 52 degrees over 68 like this. So that was going to be 0.822 and so on. So that's 0.8227 and so on, these decimals and so on. So remember, just like what we had in our normal trigonometry, where you were finding the angles, you are given that the sine of x is equal to 0.5 and you want to find x, you are going to use x not actually as x, but you're going to obtain what you referred to as the reference angle. If you still remember that concept where the reference angle is equal to the arc sine of 0.5. It is the same thing with this part that you are going to have. You are going to obtain the same condition just like of the reference angle. So let me just write in terms of that reference angle that you understand. Remember, the reference angle is arc sine of whatever that you are given here, which is arc sine of the answer that you have on your calculator. This part here, arc sine of this part, which is 0.827227 and so on and so on. So let's see what we're going to obtain on our calculator. Do not use the rounded figure just as it is like this. Shift sign like this. That's arc sine of the answer. All right. So arc sine of the answer was going to be 55.36. All right. Let's see to 2 decimal places. Just fix this again. Let's fix to 2 decimal places. That's 55.36. All right. We have got 55.36. That's the angle that we need there. All right. So if this being our reference angle being 55.36 degrees, I want you to understand that this is a triangle that you are working with. You are referring to a triangle. All right, let me bring this one. We're not done. I want to conclude this. All right, sorry for that, guys. I want to conclude this. This is a triangle that you are referring to. This concept is still applicable, the cast concept. Remember, we are working with a sine that you just calculated here from the ratio of sine. And from the ratio of sine, we do understand that these angles that we've just determined, that's considering the reference angle, in the first quadrant, we have got the angle that you want. If it is x, is going to be equal to the reference angle. If it is in the second quadrant, the x, which is the actual angle, is going to be 180 degrees minus the reference angle. Remember that concept. So in that case, you are going to have that same condition of our x being equal to the reference angle or 180 degrees minus the reference angle, which is this angle that we just determined, and that is the x that we are talking about. All right, so let's see that. So if x being equal to the reference angle, it means our x is just being 55.36 degrees, or the x is going to be given from the 180 degrees minus the reference angle. So that is 180 degrees minus this as our reference angle, which is 55.36 degrees. That was going to give us another x. But I want us to understand about this x that we are calculating. This is not we are not done. This is not a concluded value. We have not met the conclusion here. We are still finding the possible values of x because we have a condition which is referred to as the ambiguous case, which is a condition that the angles can be both applicable in the triangle. These two angles can both be applicable. Let's see that. All right. This is what you can test with. Remember, you calculated the first x, which is 55.36. So you substitute that here because we have got two possible values like we saw there. We've got two possible values. So we want to see if these two possible values are going to work or it's only one that we are going to use. Remember, we calculated our first value of x. We got that as 55.36. which is actually this one is the acute angle. So there's no way this one is going to definitely work. When I'm saying it's going to work, I'm simply saying if you are to calculate the angles in a triangle, they are supposed to add up to 180. So meaning to say these two angles, they are still less than 180. They are still less than 180. And you can even use your calculator to evaluate these. 180 degrees minus the sum of these two angles, minus the sum of these two angles, 52, plus 55.36. We can see that we are obtaining 72.64. That's 72.64. This angle is less than, it's an angle that we can have inside a triangle so that we obtain then 180 degrees, meaning to say this angle is applicable. But like I said, an acute angle is always applicable. That one is not a matter. But you have to test the other one now because there are two angles that we calculated there. So let's test the second one. The second one, which is from the second quadrant, from the reference angle concept, we saw that sine is considered to be positive in both quadrants. The first quadrant and the second quadrant, which is of 180 degrees minus the reference angle, and we got 124.64. All right, let's take this value and test it. If x here is 124.64, 124.64 degrees, let's test and see. Are we going to obtain the angles, the normal property of a triangle? If we subtract this from 180 degrees, we are supposed to obtain a certain value there. 124.64 plus 52 degrees. We are obtaining a certain value, even though it's very small, 3.36 degrees. Meaning to say it's possible for this angle to be 124.64. These two angles, if you add them, they are less than 180 degrees. So as long as you obtain an angle and you add these two angles, they are less than 180 degrees. That angle is applicable. You can use that angle on your solutions. But if you obtain a certain angle, let's say you obtain an angle here, which is more than what we are expecting there. Let's say you do your calculations and the angle maybe is 130 degrees. If you add 130 to this 52 degrees, you are obtaining 182 degrees, which is more than 180 degrees. So it means the angle of 130 degrees is not part of our solution if it is like that. But if you add these two, as you can see, if you add these two angles, you are obtaining an angle less than 180. So it means also this is going to be part of our solution. It forms a normal triangle. We still have a normal triangle. So therefore, in this case, the solutions were going to be both. X was going to be 55.36 or 124.64. That is the ambiguous state that we can have. So always test for that. When calculating for an angle, you might have a state of this nature. So you need to test whatever that you are given there. All right. So that was our question. Let us test this. Okay, this one is just a side. So that one is just direct. We need to calculate the angle X. Okay. So that is angle X. I mean, the side X. So from the side X, we need the angle corresponding there, which is at B. We saw this from question number 2, where we had to calculate this angle here. So it's the same thing that we are seeing here. From these two angles, you are going to calculate angle B, which is a direct because we've got two angles in a triangle. So the angle at B is simply going to be 180 minus the sum of these two angles, 108 plus 42 degrees. All right, so that is the difference that we have, 180 minus 108 minus 42 was going to be something like 30 degrees. So that's 30 degrees. So meaning to say, if this angle is 30 degrees, we can use our sine rule to calculate X because we have got the condition that best suits our sine rule. The side opposite to the angle, another side opposite to the angle. So it's a side pair concept. So X over this just like what we had before. This is side, so you're just going to have A over the sine of A is equal to B over the sine of B, where A is the side that you are calculating. So you're just going to call it X over the sine of the angle corresponding there, which is equal to the B, the side corresponding to another angle. So that is 163 degrees over the sine of that angle that is corresponding of 108. So that's it. We can calculate our X. So this one is just a repetition. Calculate this, multiply by sine 30, multiply by sine 30 here. So this was going to cancel. So our X was going to be this value, which is direct on our calculator. So this one, it is just a repetition of what we saw on question number 2. So our calculator already fixed to 2 decimal places. So that's 163 times the sine of 30 degrees, everything divided to the sine of 108. So that's it. We are going to obtain 85,69. So that's 85,69. And this is length in centimeters. Use the given units that you have got there. So in terms of the sides, we do not have that part of the ambiguous state where you need to know. In terms of the sides, it's just a direct situation that you're going to have. So the ambiguous state is on a condition where you are calculating angles. So question number 5, we are going to try that and see if it is going to work. All right. On question number 5, you need to calculate X, and X is an angle. So you can use the sine rule again because this angle is corresponding to the side. There is an angle corresponding to the side also. So let us use our sine rule. Sine of A over A is equal to the sine of B over B, meaning to say the sine of the angle that you are calculating, which is X, over the side opposite is equal to the sine of the 100 degrees over the side that is opposite, which is 18. So that's it. We can calculate our X simply in this case, multiply by 15 both sides. So this can cancel. You remain with the sine of X equal to the decimal part that you are going to obtain. So let us just, in this case, let us just have this way. I'm just going to remove this back to the normal mode because we need exactly the decimal that we were given there. So this is sine of 100. This is sine of 100 degrees times 15, which is simply 15 times the sine of 100 degrees divided to 18 like this. So it's going to give us a decimal just like the previous case, 0.820 and so on up to, we do not know. So this is an endless decimal where we need to calculate the reference angle, and we saw that the condition there is simply the reference angle, which is just X, and subtracting that from 180. So guys, that is the same X that you are going to have, which is simply arc sine, which is shift sine of the answer, just like what we have that we had before. So that was going to be 55,15, which we can fix this to 2 decimal place. That's 55,15, as you can see, 55,15 degrees. All right. And we saw that we have got the condition of the ambiguous state where we need to take this from 180 degrees because the reference angle, we understand the sine from all and this other quadrant. So it's going to be 180 minus the reference angle, which is the 55,15. So we are going to obtain another X as 180 minus 55,15 degrees, which is, let's say, 180 minus 55,15 degrees. That was going to give us 124,85 degrees. So like I said, it's something that you need to test and see if it is going to work or not. So using the acute angle, definitely the acute angle is going to work. When I'm saying it's going to work, it is when you substitute this X here that you calculated, where the X is 55,15 degrees. As you can see, if you add these two angles, they are less than 180. So even if you calculate B, you're going to obtain an exact angle B. So this angle is fine. But you have to test now this other angle, which is the obtuse. The acute angle, don't worry about it. You test the obtuse. So is it possible that x can be 124 here? Is it possible that x can be 184.5 degrees? Is it possible? Add these two angles. See, they are giving, if you add 100 plus this, it is going to give us 224.85 degrees, which is bigger than 180 degrees. That's actually impossible in a triangle. Angles in a triangle, they are supposed to be equal to 180 degrees. So this does not work. This angle cannot be that, because once you have a 124.84, just add it to the other angle. It is more than what a triangle is supposed to give you. So this here is not going to be part of our solution. It is not going to be part of, but we have to test, because you do not know. So you have to test. So therefore, our x in this case was going to be 55.15, not this one. Not this one. X cannot be equal to this. So test for that ambiguous state. Is it happening or not? All right, last question, let us also consider, because it's also an angle that you have, so you need also to test. We have got this x corresponding to what? We do not know. But there is 80 corresponding to an angle, and there is a side corresponding to an unknown angle. So instead of you calculating x, ignore that. Work with what is corresponding, A to 65 degrees. Also, the 80 to the 67 degrees, these two. There is something that you can use there. So remember, your sine rule does not change. So meaning to say, the sine of the angle that we want to calculate at A over its corresponding side is equal to the sine of the angle that we are given, also 67 degrees, over the corresponding side of 80. All right, so let's multiply by 65 this side. So this can cancel, meaning to say the sine of A is equal to the decimal part that you are going to obtain from your calculator, which is, in this case, we gonna just have something like this: 65 times sine 67. All right, 65 sine 67 over 80, like this, over 80. That is 0.7 7479 and so on, 7479 and so on. All right, so like I said, the reference angle concept, so you're going to calculate the angle A from the arcsine of the angle, which is shift sine the answer. All right, that is 42, so that was gonna be, okay, let's fix this to 2 decimal place, 48.41. So we've got 48.41 degrees. So this is the A that we are calculating on this part, and we need the x that is gonna remain in that case. So in this case, it's true that you are actually calculating the angle in that case, but it is not the one that we are to focus with. A is true, we can have two angles there from the ambiguous state that we had, 180 minus this one. So I want us to see something there, but it's not that important when it is like this. 180. All right, 180 minus 48.414, like this. You were going to obtain 131.59, which actually can work in this triangle. Let's see, because there we have got a 67. Let's see if it's going to work, because we are saying if we add this 67, remember, 67, all right, that is more than, no, this was not going to work. So the other angle was not going to work. It was going to be more than 180, as we can see. So meaning to say the other angle was not going to work, but you have to test for that ambiguous state. As we saw, the other angle was not going to work. This was the only angle that was going to work for A, not for X. This is for A. But the angle that works for A is the same angle that you're going to use to calculate X. Why? Because we have got angles in a triangle. So we saw that the other angle that we're going to have was not going to work. So the A that we are going to use is the 48,41 degrees. So if this A is 48,41 degrees, what about X? Angles in a triangle, they add up to 180 degrees. So we can subtract the 48,41 and the 67 degrees together from the 180 degrees that is obtaining the value of X in that case. So you have to be very, very careful in the proving part, in the testing of the conditions that matches the triangle. Is it going to work or not? You must test that condition of the ambiguous state, whether it is going to be successful or not. All right, so if this if this A is 48,41, therefore our X is going to be 64,59. So therefore our X is going to be 64,59 degrees, as we saw that the other angle A was not going to match, was not going to work. It's not always where you take both answers, acute and the other obtuse angle. No, you test for the ambiguous state. Is it working or not? If you take the answer, you add it to the other angle that is inside of the triangle that you have. It must be less than 180. Once it gives you a direct 180 or more than 180, that is totally wrong, because we know that all the three angles in a triangle must add up to 180, not two angles, but the three angles. So if you take this angle, you add to this one, it gives you more than 180 or equal to 180. It means that angle is not part of your solution. So that's how you test it. So let's work with more questions, more revisions that can help to answer as many questions as you can, especially in typical exam questions. How are they going to ask these questions? You must be careful of these two. Let us see in our next class, applications.